Shell molding offers a high-accuracy approach to sand casting. By creating a precision-engineered resin-bonded skin, manufacturers can produce complex geometries with greater detail than traditional methods. Instead of using massive molds made of loose sand, shell molding utilizes a rigid 6mm resin-bonded skin. This skin precisely mirrors the pattern surface, reducing material usage and creating smoother, more intricate cavities. Shell molding bridges the precision gap found in traditional green sand casting. It delivers a superior surface finish and higher dimensional accuracy, significantly reducing the need for heavy post-cast machining. This process relies on two fundamental upgrades: heated tooling and active binders. Highly engineered metal patterns are heated to react with thermosetting, resin-coated sand, which remains loose until thermal activation creates a rigid structure. The shell is formed through localized thermal transfer. As the sand contacts the hot pattern, it cures into a stable shell. Excess unbonded sand is then removed and can be reused for subsequent operations. Clean separation of the hardened shell is essential. Using precise draft angles and ejection pins, the shell is released from the pattern without damage, allowing for the assembly of two symmetrical halves to form the final mold. A 6mm shell lacks the strength to hold molten metal on its own. To defeat hydrostatic pressure, the shell is supported by backing material, such as sand or metal shot, ensuring structural integrity during the pour. While shell molding revolutionizes the external mold, it maintains compatibility with traditional sand cores to generate internal hollows, ensuring complex internal geometries remain achievable. The accuracy of this process stems from a sequence of precision steps, using machined patterns, direct thermal bonding, and rigid shell formation. These elements combine to resist deformation, resulting in high-fidelity casting output. Shell molding supports various metals, including cast iron, steel, and alloys. The primary constraint is thermal. Engineers must ensure the thermosetting resin can withstand the specific pouring temperature of the chosen metal. This diagnostic comparison highlights the trade-offs. While shell molding incurs higher tooling costs than green sand casting, it provides superior dimensional accuracy, better surface finish, and requires less post-process machining. The engineering upside is clear. Shell molding consistently delivers near-net shape components. Its repeatability, combined with the ability to replicate complex details, makes it a reliable choice for high-precision manufacturing. However, there are constraints: high tooling and material costs, potential geometric restrictions regarding undercuts, and the need for proper ventilation due to thermal fumes must be considered in the operational planning. When selecting a process, evaluate these criteria. If your production requires higher accuracy and superior finish, and your budget allows for initial tooling investment, shell molding may be the optimal solution. In summary, shell molding offers a robust framework for high-precision casting. By balancing materials, thermal processes, and design constraints, manufacturers can achieve consistent, accurate components efficiently.